This is a tutorial for the study guide for Chapter 4, Section 6, Chapter 4, Section 7. So let's take a look at our first problem that we're going to end up seeing on the test. It says to write an equation of a line in slope-intercept form. And so a couple of ways we could do it, but since we have the graph, I'm just going to end up using those 2 points to help me find the slope. Always look at the intervals that you have. Notice these are not going up by 1s, these are going by 2s. So one space is actually 2 spaces. So here we're at 7. This is 4, 6, and 7's in between. And that's 1 space to 8 and another space to 9. Notice how we went from 7 to 9. So I end up having to go up 2 spaces and then just over 1 space, because notice how it goes by 1s over here. So my slope is 2 to 1, and so that's just 2. And then I'm looking for my y-intercept, b. Well, the y-intercept is where it crosses the y-axis, so it's right there at 0, 7. So 7 is the y-intercept, and we write the equation in the slope-intercept form. Y equals mx plus b. So all you're doing is substituting the 2 in for m and the 7 in for b, and that's our answer. In this next one, we're trying to write the equation in slope-intercept form again, so we count the spaces. Here we're going by 1s when you look at the intervals. Same thing on the x-axis. So I go down 1 space, and then I go over 3 spaces. So since I went down 1 means that it's going to end up being -1. So down 1 space, that means -1. And then I end up going right 3 spaces. So that slope is going to end up being -1 to 3. And so I need to find the y-intercept now. Again, you're looking for where it crosses, and right there it is, 0, 1. So 1 is the y-intercept. We do the same thing, write it in the slope-intercept form. So our answer is y equals -1/3 x plus 1. On the next problem, it says a rattlesnake is 5 inches long at birth. And so what the b represents in the slope-intercept form, y equals mx plus b, is the beginning point. So that represents beginning. And where does it begin? Well, it begins at 5 inches. So 5 inches is going to end up representing our b value. Then we're looking for the slope. The slope is the rate of change. And so we're looking for a change in y. So change in y over a change in x. And so I see 7 inches per year. So right there, that word per typically tells us that's what the slope is going to end up being when we see that word there. It usually represents a unit per unit. And so that's what we see here. So 7 inches is the slope. So it wants us to write an equation that represents the y length of a rattlesnake over x years. And so we're going to write it in this form, y equals mx plus b. And since the rate of change of the snake is 7 inches per year, times by the input, which is the number of years, plus the original length of the snake, which was 5 inches, is going to equal the total length of the snake, which is y. So this is part of the answer, because it asks us to write the equation. Now we're going to substitute. I'm going to take 10 and substitute in for that x. So I've got y equals 7 times by 10, because that's the number of years, plus 5. So it's going to be a total of 35 inches plus 5 is going to give us 40 inches. So let's take a look at the next type of problem. And it says use the point slope form to write an equation. So I'm going to use point slope, but I'm going to end up writing it in the slope-intercept form for this problem. So it passes through this point, and it's given this slope. So this point is -2, 0. So I'm going to use that point in point slope, which goes this way. Y minus y1 equals m times x minus x1. And so I end up substituting. I've got y minus 0 equals the slope. The slope is 5 over 2 times by x minus -2. So a minus negative makes a plus positive. We distribute, and we've got y minus 0 equals 5/2 x. And then here, 5/2 times 2, the 2's end up cross-canceling. 2 changes to a 1, multiplying by the numerator leaves me with 5. And so that'll be my answer. There's nothing to move over to the other side. So I've got y equals 5/2 x plus 5. So taking a look at the next problem, I end up having to write in slope-intercept form for a line that passes through these 2 points. So I first need to find out what the slope of the line is. The slope of the line is the change of y. It's the change of the y values over the change of the x values. So these are my y values right here. Those are the change of y's. So these are y minus y1. So I'm going to write down -4 take away 1. So since I started at the -4, I've got to start with that same point's x value. So I'm going to subtract these 2 values. That's the x minus x1. So 3 minus -2. So that ends up giving me -5 over +5. Because again, I added the opposite. So I'll show that step there. So here I added the opposite, got the -5, add the opposite, I got +5. So from that point, I end up reducing that fraction, and that gives me -1 for the slope. So I'm going to use that slope and use one of the points. So either point works. So pick either point. So it doesn't matter which point you pick. You just pick whatever seems easier. So I'm going to pick the first point. I'll use -2, 1. That's the point I'm going to use. And I use the slope, and I put it into point slope. Y minus y1 equals m times x minus x1. So when I do the work, I've got y minus 1 equals the slope, which was -1 times x minus -2. So anytime you see that minus negative, remember that just makes a plus positive here. And then you can go ahead and distribute. So when I distribute, that -1 is going to switch the sign, so I get -x minus 2. From there I have to add the 1, and I'll get the answer y equals -x minus 1. So moving on to the next problem, it says Ed's car depreciated. So there's key words that help us figure out signs, and this is one of them. Depreciates means that we're going to end up having a negative number to help us depreciate something. So depreciates by 2,000 each year. So remember I said per helps us figure out that's the slope? Well, each also helps us out. And we got 2 different units. We got dollars and years. And notice when we read down further, it says y is in dollars and x is in years. So since the variables, y over x, represents dollars per year, that tells us that the slope has to be this $2,000 each year. So this is a negative slope. So we're going to use that. And then it gives us this. So notice again how x was in years. X represented years, and the y component of the ordered pair is the value in dollars. So that's going to be the ordered pair. Notice as we read this next sentence, it says after 3 years, his car is worth $18,000. That is an ordered pair. That is years, 3 years for $18,000. And so we're going to use this point and this slope in point slope. Y minus y1 equals m times x minus x1. So I go ahead and substitute y minus 18,000 and then equals my slope of 2,000, but it's negative because I'm depreciating, times by x minus 3. So we'll go ahead and distribute, and we have now y minus 18,000 equals -2,000 x plus 6,000. So from that point, I just do opposite operations. I'll add that 18,000 to both sides, and I'll end up with 24,000. So y equals -2,000 x plus 24,000. So that's the equation. So they said to write the equation to represent the situation. And then they say, what was the original value? Well, remember what I had mentioned before. In this slope-intercept form, y equals mx plus b. B represented the beginning value, or another word for beginning is initial. So that's the initial value, the starting point. And so our starting point is that y-intercept. So $24,000 is the original original value. And then they ask this, how is this represented in the equation? So we'll say, which is represented by the y-intercept. So that answers that last question. Let's take a look at the last couple of problems. It says describe two ways you can find the measure of angle B. So B is right here. This is the one we're trying to find. So the first step is, remember there's only two angles here. We have parallel lines. The blue lines are parallel. And that means that all the acute angles are congruent and all the obtuse angles are congruent. So let's find the other angle. Let's subtract 52 from 180. And when we do that, we end up with 128. So I know all those obtuse angles, B, C, E, and F, are all 128 degrees. So I know that. And so now I have to show that. And so the way I'm going to show that is this. I'm going to start at the 52 degrees, and I'm going to try to find the measure of angle A. I'm going to say the measure of angle A equals 52 degrees. The reason I know that, well, it's one of the acute angles, but it's also corresponding. So because it corresponds to the given. So it's a corresponding angle to the given. They're in the same location with respect to the transversal. And then I can say the measure of angle B equals 128 degrees because it is supplementary to angle A. So that is one way. Now a second way would be this. We could say the measure of angle D is also equal to 52 degrees. And the reason is that it is alternate interior angle to the given. So now we have this angle, angle D. So 52 and D are alternate interior, alternate sides of the transversal inside the two parallel lines. And then we could say angle B is equal to 128 degrees because it is supplementary to angle D. And so those are two different ways to show what angle B is. On the next problem it says these two figures are similar. And so I know they're similar because if you look at these different angles here, these two angles are congruent because they're both vertical. We've got the right angle, which would mean this angle equals this angle. So if that's the case, if I turn this around, I pivot this right about this point right here, this angle will line up with this angle. And so what I'll do is I'll set up proportional sides. So I would say 18 is in relation to or corresponds to 90. And so that means that since I started with this triangle here, I'll do 20 is corresponding to D. And so I'm going to reduce this. I'm going to take out a common factor from these two terms. And right away I saw 9, but that can go even further because that makes 2/10. So I can go even further and take out a 2. And that makes 1/5. So 1/5 is the same as 20 over D. So all I have to do now is cross multiply. So multiply the 5 times the 20 and the 1 times the D. And you go ahead and multiply. We got 100. So 100 feet. That's how long side D is. So the last one says Ed works 40 hours per week. And on this one, I'm going to change this to the work week is 5 days. So 5 days. So 40 hours in 5 days, we'll say. Sue works Monday through Friday because that's 5 days. And the table is shown. So it doesn't give us all of her data. So what they want us to do is in the same coordinate label and graph the equation or axes, and then we're going to graph the two and who works more per week, it says, and the week is the 5 days. So we're going to label the x-axis, we're going to label this number of days. And we'll just go by ones, so I'll just write down every other number here. So 2, 4, 6, and so on. And then the y-axis represents hours worked. Hours worked. And here we won't go by ones, we'll go by fives. So I'm going to write every other number. And we can go ahead and fit in Ed's line first. So Ed doesn't work any hours at 0 days, so that's where we start. But he works 40 hours in 5 days. So 5 days is right up here. And then we'll draw the line between those points. And then we'll label that Ed. And then I look at Sue, and Sue works 1 day is 7 hours. So 1 day is 7 hours. Now it's not quite on the line, almost looks like it's right on this line. So I'm going to continue it out. 2 days is 14, so you can see how that's going to be just below here, like right around there. 3 is 21, so 21 is just above this line here. So you can see how it's just below this line. At 5 days, we'd be at 35. And I got that because I see every day it's just adding 7 each time. So at 4 it would be 28, and at 5 it would be 35. So that's the line there, so we'll draw that line. And so you can see how Sue's line is less steep than Ed's. And so that helps us out. It says, who works more per week? Well, Ed works more. He works 40 hours. Sue only works 35. You can see it. After the 5 days, Ed is higher than Sue. So we'll say Ed works more per week. And we're comparing the steepness of the graph. So because his line is steeper due to its greater slope. So we're trying to relate the steepness of the graph to answer the question. Since they want to know who works more, well, Ed works more. His line's steeper. And the reason it's steeper, well, his slope is greater. And so those are the questions that we're going to see on this week's test. Good luck.